Today you'll be doing 5.4 compound inequalities. At the end of this lesson you'll be able to solve and represent a compound inequality. You will also be graphing the compound inequality. A compound inequality is an inequality that has been joined by the words and or. A conjunction is a compound inequality that involves the word and, while a disjunction is a compound inequality that involves the word or. You'll be representing two equations or two inequalities when you're doing a compound inequality. Conjunctions are compound inequalities in which the solution must satisfy both parts of the inequality. The solution is either this number and this number. It represents the endpoints of your number line. The conjunction is all the answers in between, possibly including the two endpoints. Example, x is greater than -2 and less than or equal to 5. It is expressed as the inequality -2 is less than x, which is less than or equal to 5. Showing all solutions are in between -2 and 5, including the answer of 5. So the way you could graph it, I'm going to put an open dot on -2, a closed dot on +5, and show that x must be in between there with the line connecting the open and closed dot. That is the graph of the compound inequality. -2 is less than x, which is less than or equal to 5. Showing all the solutions are in between -2 and 5, including 5. -2 is not an answer. It is every part after -2 up to 5, including 5. A disjunction is a compound inequality in which the solution only has to satisfy one part of the inequality. Example is x is greater than or equal to 3 or less than -4. This can be expressed as the disjunction x is greater than 3 or x is less than -4. There are two parts. Only one of these needs to be satisfied, either x greater than 3 or x less than -4. So the way I graph it, I'm going to put a closed dot on 3, an open dot on -4, now to show x greater than 3 or equal to 3, everything greater than goes to the right. X less than -4, everything less than, which is to the left. So my solution set, or the numbers that make this inequality true, are going to be on this side of the number line, including 3, or this side of the number line, not including -4. Everything must be less than -4 on the left, greater than or equal to 3 on the right. This section in the middle is not part of the solution. The solution sets are greater than or equal to 3. So this right-hand side, everything over here, or the right-hand side, everything over here that is less than -4. So there's a warm-up to review what we did in 5.3, solving a single inequality and then graphing it, and then we'll move on to the compound inequalities. So in warm-up number 1, I first use subtraction property of equality. So negative 4x is less than or equal to 8. Then division property of equality, divide by negative 4 to isolate the variable. So my answer is x is greater than or equal to. Remember, you have to flip the symbol when you divide by a negative, and it's negative 2. So my inequality is x is greater than or equal to negative 2. So when I graph it, negative 2, close dot, and then it's greater than or equal to, so everything to the right. Number 2, I have to distribute first. 4x minus 24 less than or equal to x plus 30. Now I want to move the x's to one side, the numbers to the other side. Subtract x, subtraction property of equality. Add 24, addition property of equality. Kind of combining two steps together so that I get 3x less than or equal to 54. Division property of equality, divide by 3 on both sides. So I get the inequality x less than or equal to 54 divided by 3 is 18. Didn't have to flip the symbol because I didn't divide by a negative number. So when I graph it, 18, a closed dot, x less than or equal to, so I go to the left. Everything less than 18, 18 is a closed dot, so it is included in the solution. Number 3, distribute the negative. Negative 3 plus x greater than or equal to, distribute the 2, 6 minus 2x. Same thing as number 2, get the x's on one side, numbers on the other side. Addition property of equality to move the 2x over. Addition property of equality to move the 3 over. I'm doing 2 steps in one. And I get 3x greater than or equal to 9. Division property equality to isolate the variable. And I get x greater than or equal to 3. Three goes on the number line with a closed dot. I didn't have to flip my symbol because I didn't divide by a negative number. X greater than or equal to, so everything to the right, greater than 3. Alright, so now I'm going to get into my compound inequalities. So the first one says, given the following compound inequality, solve for x. Negative 11 is less than 2x plus 5, which is less than or equal to negative 3. I'm going to have 2 answers to this inequality. Everything I do to the middle, the 2x plus 5, I'm going to have to do to the left side where the negative 11 is, and the right side, the negative 3. You're kind of like solving 2 equations at once. First thing I need to do is subtract the 5. So when I do my subtraction property of equality, I want to do it to everything. I want to do it to both parts of the inequality. So now I have negative 16 less than 2x less than or equal to negative 8. Now I want to isolate the variable using division property of equality. Divide by 2, divide by 2, divide by 2. Everything gets divided by 2. So negative 8 less than x less than or equal to negative 4. So I'll jump down to B. It says, what type of compound inequality is this? It looks like it's going to be a conjunction. A conjunction will always show you the endpoints that you graph, and x must be in between those values. So I'm going to be shading in between those values. So I put an open dot on negative 8. I put a closed dot on negative 4. And now to prove that I shade in between, I need to have my shading be x greater than negative 8. So greater than goes to the right. And then x less than or equal to negative 4. Shading to the left. My two arrows meet each other. So then I shade in between negative 8 and negative 4. Showing the answers to this compound inequality are every answer in between negative 8 and negative 4, including negative 4, because I have the closed dot on it. So this is a conjunction. It would have and in it. So part A says, what values satisfy the solution to this compound inequality? The values that satisfy the solution are every single number between negative 8 and negative 4, including negative 4. So I can write it like we did with domain. I can write it as an interval. An open dot represents a parenthesis. Negative 8 is the lowest number it can be, comma, negative 4 the highest, with the hard bracket to represent negative 4 is included as a solution. So my interval is negative 8 to negative 4, including negative 4. Given the following compound inequality, solve for x, negative 32 greater than negative 5x plus 3, or x minus 4 less than or equal to 2. This appears that it's going to be a disjunction, but I won't know until I graph it. So I'm going to first solve each inequality separately. I'm going to take the left inequality, subtraction property of equality, subtract 3 from both sides. Negative 35 greater than negative 5x. Use division property of equality to isolate the variable. Negative 35 over negative 5 becomes a positive 7. Flip my symbol because I divided by a negative, and x. So now I have x is greater than 7. Now I need to solve the other part of the inequality, the other or. Add 4 to both sides using addition property of equality. So x is less than or equal to 6. I need to graph each part now. So whenever I graph this, I'll graph my first inequality, x greater than 7. 7 gets an open dot on it, and then I'm going to shade to the right for everything greater than 7. Then graph the OR part of it, x less than or equal to 6. 6 gets a closed dot to show it's equal to, and then the less than part is everything to the left, and I get a disjunction. So the OR is true because my arrows go opposite directions. They don't run into each other like a conjunction. So I'll go down to B. What type of compound inequality is this? It's a disjunction. Because I have OR at the beginning, and because my arrows go in opposite directions. So what value satisfies the solution to this compound inequality? All the solutions are everything to the left of 6, including 6, or the solutions are everything to the right of 7, not including 7. So I can write this as an interval as well. It's a little different than you've seen in the past. I know the first part of it, my left-hand part of the solutions, negative infinity is the minimum, 6 is the maximum with a hard bracket. I know the right-hand solutions, 7 is the minimum, positive infinity is the maximum, because my arrow is going to go all the way up to positive infinity. Infinities always have a parenthesis on them, just like a open circle. And the last part you need to add in is a U for union, meaning it's every part of the left side plus every part of the right side. The only part that's not a solution to this inequality is this section in the middle, in between 6 and 7. That's not a solution. The only parts of the solution are to the left of 6, including 6, and to the right of 7. So my interval goes from negative infinity all the way up to 6. It includes 6. Then it jumps over until it hits 7, but doesn't include 7, and then runs all the way to infinity for all my solutions. So the last thing we need to talk about is a word problem. Just like we did in 8.3 we had a word problem, we're going to have a word problem here. Anna wants her son to start reading more each day. She said he must read at least 20 minutes each day, but not to read more than 60 minutes, so he has time to finish his other homework. We're going to write an inequality that represents her son's reading time. I need to first identify my variable. X is going to equal the amount of time reading. When I look at this, I have a minimum number that he must reach, which is 20 minutes, and a maximum number that he must reach, which is 60 minutes. So to me, this looks like it's going to be a conjunction. He's got to read in between 20 and 60 minutes. So if I write the interval, it says at least 20 minutes. So 20 minutes is the minimum. He cannot read less than 20. And then it's going to go all the way up to no more than 60, a maximum of 60 minutes. Hard brackets on both because 20 is included and 60 is included, and every single minute in between there. So if I had a graph, I would have a minimum number of 20, and a maximum number of 60, 20 minutes would be a closed dot. 60 minutes would be a closed dot. And the rest of my solutions would be everything in between. Every single minute in between 20 and 60. So if I had to write an inequality for that, x is the amount of time the sun is spending reading, 20 is the minimum, 60 is the maximum. I always want my symbols to be facing the same way. So 20 is less than or equal to x, which is less than or equal to 60. Showing all my time spent reading must be 20 or 60, and everything in between there. Every minute between 20 and 60 is a possibility for Anna's son to be reading.